Hi, this is the answer key for quick check number 2. The first question was asking you to multiply 89 times 63 using generic rectangles. The reason we like to use generic rectangle is because it helps us to understand the place value system. So let's get started. The first thing you should have known is to break down the numbers into their place value system. Now, I taught you how to create a t-table in order to create these numbers and separate them. So once I create my t-tables with these numbers, I understand that the 3 is in the ones place and the 9 is in the ones place. I also understand that the 6 is in the 10th place and the 8 is in the 10th place. Once I have broken down my numbers, I can start creating my generic rectangle. Now my rectangle is going to be a 4x4 rectangle, and you'll understand why right now. On the top, I'm going to go ahead and place the 89. And the way I do it is, I know that this spot is the ones place, and I know that the 89 says that I have 9 ones, so I'm going to place the 9 there. I also know by this number that I have 8 tenths, so I'm going to place that right here, and I'm going to say 80. I can check my work by saying 80 plus 9 gives me 89. I'm going to do the same thing with the 63, but this time I'm going to go in the vertical direction. So the number above is 6 tenths, so it's 60. The number below would be my ones place. 3 times 1, or 3 ones is 3. Once I've created my generic rectangle, all I do is I multiply it using smaller or numbers with 0 in the ones place, which is a lot easier for students or for any adult. 60 times 80, well, I know that 6 times 8 is 48. Hundredths, the zeros. 60 times 9, well, I know that 6 times 9 is 54. I'm going to add a 0 because I'm multiplying by 60. 3 times 80 is 240. And the last rectangle is 3 times 9, 27. Now when I add all these numbers, or all this area, I'm going to get the answer to 89 times 63. So we line up those numbers inside, nice and neatly. And I start adding. So my answer to 89 times 63 is 5,607. I can check my work by doing the regular algorithm that we're used to, and I will get the same answer. So that's question 1 in quick check 2. Let's go to question 2. Question 2 gave you 2 figures. We're not going to worry about this figure until we try to find this one. And what they asked you about this figure is that they wanted you to find the area. But not the area of the whole figure. They only wanted you to find the area of the shaded region. Well, from class, I know that finding the area would be length times width. So I know to get the area of the big rectangle, I would multiply 12 times 5, which would give me 60. However, they seem to have cut this little piece right here, and I don't want that piece. I just want the shaded region. So I would find the area of this piece by multiplying 8 times 3 and getting 24. Since they cut this little area off, I will subtract it from my entire area represented by the 60. Once I do my subtraction, I notice that my area is equal to 36. Do not forget 36 centimeters square. So once you found the area, the next problem asked you if Francesca was right. Francesca used generic rectangles. Now something that should have made you think was that Francesca was right. And the reason why Francesca was right is because what she did is she grabbed this inner rectangle and placed it all the way on the top corner. Once she placed it in the top corner, she got two generic rectangles that represented this area right here. She got this smaller one, and then she got this larger one. And what Francesca did is that she figured that the area of the rectangle that is shaded like this was 3 centimeters, which she got from here, times 4 centimeters, which she got from subtracting this small little area from this larger area. And she figured that this was 12 centimeters square. Then what she did is she got the area of this larger rectangle by multiplying 12 times 5. Oop, forgive me, I made a mistake, sorry. 12 times this entire area minus this little area right here. Sorry about that, I went off screen. This entire area, which was 5, we take away this area, we don't need that area, which is 3, giving us 2 centimeters. Once she did that, she got 12 times 2, which is 24 centimeters. Then she added them and got 36 centimeters square. The same answer that you should have gotten when you found the area, just a different way of approaching the problem. That's one thing that we have to learn in 6th, 7th, and 8th grade math here at Dana. We have to approach the problem in different ways. Problem number 3 on the quick check was something that you needed to remember from section 1 or chapter 1 that we did. And all it asked you was to graph these 3 points. A key that you should have done was mark these as x's and these as y's. Now I understood that these are my x-axis and this is my y-axis. Now to graph -2, I would crawl to -2, then walk to -2 and place my point. I would do the same thing with the second point. Crawl to -4, down to -2. I would do the same thing with the last point. Crawl to -4, walk to -4. Now the problem asked you to connect the dots. And I believe I even told you in class, connect the dots. Then the problem asked you, what is the area of this figure? Knowing what you know about rectangles. So as soon as you saw the word rectangle, you should have thought of length times width, or base times height. And you should have known that this wasn't a rectangle, but you could actually create a rectangle by putting some imaginary lines like this. Once you saw that, you should have known that it's a 2 by 2 So for a rectangle, the area would have been 4 units square. However, once you took those imaginary lines off, you should have noticed that a triangle is half of a rectangle. So all we wanted was half of the 4 unit square area, which should have been 2 units square.